This lesson is part of the TI-Nspire CAS Technology student course. In this lesson, we will look at creating and measuring triangles in the geometry application. Open a geometry application 1.1. Press Menu, then Settings. Tab or down arrow to ensure that the last category automatically label points is selected, like I'm showing here. Press Enter or the down arrow key to OK. Now notice the upper right corner of your screen, where the scale shows how long 1 centimeter is displayed on this screen. This will help when estimating lengths before actually measuring them. Let's create our first triangle by pressing Menu, then Shapes, then Triangle. Now notice 3 things on your screen. First, the cursor in this Shape Creation submenu looks like a pencil with a point at the sharp end. Second, there's an icon in the upper left corner, which tells us that we're in the Triangle Creation submenu. And third, when we guide the cursor up to this icon, the instructions of what we need to do are revealed. Move the cursor towards the left middle edge of the screen. Click to place the first vertex of the triangle. Then repeat that action at 2 other locations on your screen. Notice how, when you move to the second point, the spiderweb trail is left behind, helping you to guide your selection of the remaining points B and finally C. Notice how when the third vertex is placed, the triangle edges are made bold briefly. This stops when you move the cursor, still a point and pencil, away from the perimeter. At this stage, press Escape, which turns off the icon in the upper left corner, ensuring that you have removed yourself from the Triangle Creating submenu. As you move the cursor back to the perimeter of the triangle, notice how it's now an open hand, and the triangle is named. Close the hand, which grabs the triangle by holding down the keypad, and now use the touchpad to grab the triangle and move it to other locations on the screen. Notice how its shape remains the same. Press Escape to remove your grip. Now move the cursor to a vertex. Let's say point B. Once Nspire recognizes that you have arrived at that point, notice the tab sign that appears there. This indicates that there's more than one object at that location. Press Tab a couple of times to notice that you could be selecting either the point itself or the triangle ABC or its label. Now, always pay attention to the geometry screen as there are messages there to help you. With the open hand appearing at point B, close the hand and grab that vertex as done before and move it. The other 2 vertices remain in place, but the triangle's shape will have altered. Press Escape to release the grip. Try this with other vertices. Say point C. Release the grip. Point A. Release the grip. Then return the triangle to a location and a shape you're comfortable with. I'm going to bring A down here so that it's vertically across from point B. I'm going to grab the whole triangle and just move it down a little bit, and you'll see why in a little while. Okay. We'll now measure the area and perimeter of triangle ABC. There are a couple of ways to do this, but the fastest is to guide your cursor over to the triangle's perimeter, where the triangle is named, like it is now, and press Control, then Menu. Choose Measurement. Then Length. This is Nspire's generic word for distance, by the way. Here, it will be the triangle's perimeter. Now, the value will appear ghosted or black as you move the cursor away from the triangle. Press Escape. Now, repeat those actions to find the area. Cursor at the triangle's edge. Menu, Control, Menu. Measurement. And this time, choose Area. Again, that measurement appears on the shape. You can use your touchpad and the click pad to close the hand over the measurement text and bring it down so it's separated from the other. You can see that one is labeled as centimeters, the other is centimeters squared, so you know which particular attribute is being measured. Now, notice that the measurements can be moved to a less busy section of the screen. So I'm going to move the perimeter up here, and I'm going to move the area up over here. You'll see why for this a little bit later, but it's a little bit less busy area of the screen. Now, if you grab a vertex to alter the shape, the measurements will change. I'll do that with point B. As I go up here, notice both the area and the perimeter are changing. I'm going to bring it back to about where it was. I'm not going to be concerned with having it exactly where it was before. Again, I release the grip. Now, let's create a new triangle, one that's similar to triangle ABC. We can do this by pressing Menu, then Transformation, then Dilation. Notice the changed icon in the upper left corner. Again, it tells us some instructions about how to manipulate and access this transformation that's a dilation. First, use the cursor to point to the outline of the triangle and click. Next, move to the point from which the dilation will be measured. Let's choose point A. Wait till it says point A and click again. Finally, to determine the dilation factor, move the cursor away from the triangle without clicking. To keep the new triangle within the original triangle, key in a decimal less than 1. We'll use 0.5 and we'll press Enter. Then press Escape to pull back from the dilation submenu. Now use the start of the measuring pathway shown earlier to measure the perimeter and area of triangle A-B-C-. Be sure you've selected the smaller triangle, like this, before accessing Control, Menu, and we'll once again go down to Measurement. We'll select Length, And that new perimeter now can be moved up to the top of the screen next to the old perimeter. Now, you might already be able to see that the new perimeter of triangle A-B-C- is half as big as the original triangle, which is what should have happened. Let's now do the same thing for area. Go back here to the triangle A-B-C-, control menu, go down to measurement. This time select area, and this area measure can be placed up here next to the previous area measure. So we've got our dimensions for both of our triangles, remembering this is from the original ABC, this is from A-B-C'. Because you used a dilation, the corresponding sides, therefore also the perimeters, should be proportional, and the corresponding angles should be equal, so the triangles are similar. The perimeter of A-B-C' looks to be half the perimeter of ABC. If we want to prove this, we can set up a calculation using menu, then actions, then text. Place the text box in a convenient location, and I'm going to put it over here. Just click there, and now key in A divided by B, and press enter. Press escape to exit the text submenu. Then press menu again, actions, and this time calculate. Guide the cursor to the A divided by B fraction, and give it one click. At this stage, you're invited to select what you want for the variable A. Move the cursor over to the smaller perimeter. And click. You're then asked to choose B. Move that to the larger perimeter. And click. The value 0.5 appears. And let's place that next to the perimeters. Just click, and then that will lock it in that location. The value 0.5 appears, and that confirms that the half as big idea for perimeter has been fulfilled. You're still in the calculate mode. Let's do the same for the areas. Let's go back to our expression, give it one click, select the smaller area for A, and for B, we'll select the larger area. Now that value is not 0.5. Looks like the area comparison is different. Your eyes should have told you that. And you may know that the area proportion, smaller to bigger, is the square of the side or perimeter proportion. Use escape to step back from the calculator submenu. Now change the dilation factor. Go down here and choose that to be, say, 0.75. Enter 0.75, press enter. An immediate change of the diagram and all the proportions, where the perimeter proportions are 0.75 as predicted, the area proportions are the square of 0.75. Finally, to measure the angles at B' and B, we'll use the menu, then measurement, then directed angle. We will click on C dash, then B dash, then A dash, and you can see the green arrow arc. We can do the same thing with the angle at B. Select C, then B, and then finally A. Press Escape to remove yourself from the directed angle location. Move the various measurements so that they can be more easily read. Both of those, as we have always seen with similar triangles, those two angles are equal. That's all for this lesson. Be sure to check out the other videos in this course.